steel carbon content. And then today we are looking at my steel as one of the main structure frame in our subject. Steel structure frame. At the same time, I'll be showing some of the frames for you to understand what is meant by frame. And we'll be looking at some of these basic principle of structure. Maybe you have learned it in your structure class, but just to recap, something that is related to steel construction, or basic understanding of structure. Yeah. All right. This is the basic mentioned to you now. Okay, my steel again. This recap is manufactured, and we show afterward. I'll show afterward how this is being manufactured in a video form, so that it can be easily understood. A lot of videos on this, but to get something that is very clear, good diagrams, good stages, and this is very important. Okay. Okay, as I mentioned here, the higher the carbon, the more hardened the steel. So it come to under like the carbon content and high carbon content. Okay, just basically some brief what they call this point on the properties of my steel. My steel can also be rewelded. Just to remind again, I like to recap this so that you remember from the previous one, so that at least some 30% of what I've been told, remember that is good enough. Later on, with the click I mentioned about the subject, then you know how to actually answer the question. Okay, my steel is highly malleable, can be shaped, does not crack, and opposed to high carbon steel that is very susceptible to breaking, as I mentioned just now. And so this property make it easier for my steel to be beaten into small sheet, to be formed into small sheet, to be shaped into small sheet. My steel incorporate high amount of iron, ferrite, and with lens magnetic properties to it. There are a lot of other compound inside the mass, but later on during the process, they will disintegrate and they will remove all these impurities away. My steel is cost effective and opposed to other carbon steel. Very cheap. My steel is quite versatile and can be easily molded into any desired shape. Okay, and we go to the next slide. Okay. Normally, what I do that I only give you this title first. Let's go to basic first understanding of structure slide. So, and then I press animation, you come up with this one. What is a structure? You know structure, and you are not third semester, and you learn some structure analysis. Have you done structure analysis? Subject?
No.
Oh, okay, that's good. That's bagus lah, because right at this now you understand what is a structure. Okay, a structure is something that will support an object or a load, so that it can stand in it. Because without structure, no load can actually be supported, and without a good structure, a safe structure, the building can collapse. This is something that engineers is good at it. Actually, they do all the calculation. So the structure must be strong enough to support its own weight, and also whatever load put on it. I mean, the own weight, I mean dead load. Dead load. And what other load is actually is a life load. Human being, furniture, whatever that's move around, or you put it add on to the floor. That is a life load. Okay, what do you mean by steel structure? Structure is a metal structure is made of structural steel. Okay, component connect and with the other to carry loads and provide full rigidity. It has to be rigid. To create this rigidity, there's a lot of systems being adopted, like a bracing system or whatnot. And structural steel is steel construction material which fabricate with specific shape and chemical composition is suited to project applicable specification. So depend on what the demand from the client. Some do big bridges, long span building, short span building, maybe huge columns, some creative, what they call this, bracing by design by architect, the engineer got to follow, this kind of thing. So it depends on what we demand, what architects demand. Okay, let's go to basic again. Basic number 2 is basic understanding of structural forces. Have you learned about this? Do you know about this?
No, I see. No, not yet.
Not yet. Okay, basic understand. This is just basic about structure. Okay, look at this, the big on the right, the big diagram here. Structure involves what they call it tension. Tension means just like your two hands pulling something, so it is in tension, right? The steel can be in tension. Certain members of steel can be in tension. And then compression. Compression is pressing. So your hand pressing. torsional is twisting, yeah, and then shear is sliding away from something. It's sliding away, shear. And then we got this bending of the combination. Basically, if you have a beam like that, the bottom is tak boleh nampak sangat, kecil kalau tension on the outside here, shear along the middle here, bend structure members also in the middle here, compression inside here. So basically, looking at this diagram yang bawah ni, you can see we relate to high-rise bearing, for example. This is how it works, Compression, that means the load. Compression is by the load. Bottom is not so much, it's more on the top load. Tension by the pull. If you have bridges, and you got this kind of pulling factor. If you high-rise bearing, it's not so much on pulling, but it's more for bridges. This is bending, because of shear, because of the load, the wind load. The beam can bend, and then torsion is twisted, like it moves around. And shearing is when the two forces, different forces from top and bottom, it can slide. The middle can slide. This just look in terms of form, something like hierarchy. In normal structure frame like what we shown here, it can slide. If the jointing is not nice, it's not good, it's not strong enough, it's not rigid enough, then it can slide because of overloading. But you mentioned here, the 5 to recognize forces, compression is shortened or crushed. Okay, tension is you're stretching, you pull apart. Torsion is twisting. Shear is pushing apart in opposite direction. One pulling the other side and the other side. Bending, stretch, or squash at the same time. Stretch is squash, bending. The bending is one. Stretch both sides and squash at the same time. Okay, this is basic. Until you will, maybe you will learn your structural methods later on. Hopefully, they will inform you about this principle. This is just principle of structure. That's why at the moment we are revising the structure analysis. Maybe we call it architectural structure. Because what I've been taught is not architectural structure, it's more engineering structure. We have a lot of calculation that normally use it. So we getting architects actually. But not for this one, the coming semester, the coming syllabus. So in relation to building, as I mentioned, compression is come from the top. The top because why? Because of loading. And the bottom, the foundation is supporting it. Tensile actually is the pulling apart. Push in and pulling apart. But in this kind of structure, it's all very rigid, so they have taken care. Every member has been designed such a way to take care of these forces. And then the torsional, it looks like more like a cyclone. Putting blue, they call it, and the building can twist. I've seen one video say that the building failure, they just built because some structure miscalculation or they probably didn't do much study on the soil test or that. They bring such things. And then the building that is not occupant, unsafe building, so all has to be demolished. So something bad to see. Until we show it in our failure of the structure members. This is just internal. The forces are called internal forces, or sometimes they call it stress. They call it building stress, or structure stress also they call it. Okay, in a component, building frame, normally wall, windows are added later to give protection to inhabitant. Okay, now it's empty structure, this concrete. Imagine this is structure. Okay, wall, all these walls, opening area for the wall, is only to protect the inhabitants. Okay, but at the same time, not only in that, but it's also to protect environmental factor, environmental threat, for example, the heat gain, loss of hot air for cold country inside, internal hot air. The load such as human being, furniture, extra is carried by this frame. Okay, all this frame. This is life load. I mentioned about life load. This one dead load. The frame, the floor slab, and everything has been fixed here. They all dead load. They call it. Dead load. Human load is this. Life load is human being, furniture, etc. And carried by the frame. There is a bridge. Bridge is a dead load, but you have furniture. You have vehicles that goes over the bridge. They call it life load. Wall have no role except for protecting inhabitants from weather. So there is no role in terms of structure here. In terms of structure, so it doesn't seem so much like this. But there are some also cases where you can use such a frame, steel frame, but once you fill up here with brick, solid brick, engineering brick, that can become part of the bracing for the wall. That it become rigid structure, so it won't. If the wind force from lateral, lateral load is wind load, lateral, it come by the sideway, and then it cannot push it because it's so protected or very rigid, make it rigid by the brick wall. This is basic understanding about structure before we go into detail. So you see one building here, this is by Calatrava, Sandy Calatrava. Torsional is just like the one we tadi kan, this one bottom torsion, but this not torsional caused by the wind pressure or what, but this is designed for. I call it torsional building form. It was designed like this to look at this in the structure. The structural form is in the play or interplay of structural form. I mean, it is show that sometimes something like a movement in the structure. But so it is designed in that way. This Calatrava has taken, if you try to learn about his engineering concept, everything like this movement, and he relates so much to body of human body. That's another one about structure forces. These are structure forces in simple beam, trusses and bridges. So these three concepts of understanding structure is applied to almost all frame structure. You have a support, it's a support, and you got beam, and there's a load, load on top here. Then the inside here is compression, and the outside here is tension, it's the tarik, it's pulling. So, similar to this one. For example, this is I-beam, we call it universal beam. Universal beam for building construction, we call it I-beam, the shape of the I. So the top member here is really under compression due to the weight compression. And the bottom layer here is under tension, this one, tension. And the central here, in the center line here is neutral. Of course, this is a bit exaggerated, the way you used to understand the kind of concept of structure. Design structure. So for architect, you just to understand this. Of course, when they design, they have taken into consideration of the load, and the whole thing is instead of equilibrium, the beam, the column, taking the load instead. It doesn't actually set as what you see here. Okay, for a frame structure like bridges, trusses, trusses, the triangulated frame trusses, when there's a load, okay, these two members is in compression because the load is pressing. Pressing. You bayangkan you create kalau dia buat eksperimen, misalnya lidi yang boleh bentuk, yang boleh bengkok, lidi tu, lidi is broomstick. Hebat, broomstick. Today you learn one Malay word, lidi, broomstick. Okay, it's made of from the leaf of coconut. The backbone of coconut leaf. That is called it broomstick. You tie these three members together, and then you start put a load. You can see that the members in compression will set a bit. Here should be set, but in this one somehow or other like it's been stretched. But you must have tight a load here. Must have a support. Tie support here. They can test it. Kalau kita if you go in the studio, we can do that. Quite interesting juga. This in case of is a combination. Something you see in the bridges and trusses. Of course, the engineers will know how to do this, but it doesn't necessarily that it be like this all the time. For example, if you look at this central frame here, this is in tension. This is compression. So the tension inside all tension. Okay, this is support here. So bridges, there be a lot of slides in the internet. You see the principle of compression tension. They have a lot on a bigger scale. I think a small scale so they can easily understand. All I need you to know to understand, just understand the basic principle. When we talk about structural frame. So far, are you okay? Are you all okay? Do you understand?
Understand.
Okay.
Yes.
Because I most important thing that in my mission here is that to make you very understand. You don't remember, never mind, but you understand. Okay. Remember is not the stage of it. You repeat many times. That is mother, what they call it, or you can remember in time. Okay, mother's memory. Okay, what's next? Next one. Okay, now we go into what I call this frame structure or structural frame. What is frame structure? Okay, a frame structure is a network of beams. Beam is horizontal, okay? All horizontal frame is called beam. And column join up to form a skeletal framework of a building. Column vertical, okay? Column vertical, beam horizontal. Floor slab horizontal. Column is vertical. Okay, structural frame carries the total load of the building and transfer to foundation. So all the total load for building, they transfer into the foundation. Maybe here got piling or pad footing or below here. All the loads have been transferred. The dead load and also the live load. Okay. Cladding is fixed over a framework or infill panel are placed between its members to totally enclose the space within the building. All this empty on the opening, I call it opening, can be clad with a cladding, can be filled up with cladding. Cladding can be steel cladding, can be brickwork, can be steel frame, timber, whatever. Depend on the situation, depend on the specification of the building. Okay, and then frame structures are usually erected from pre-made members. This is the advantage of having a frame structures because well, it is cut in a factory and then they just fix at the side. Cut in the factory, they fix at the side. Okay, that is the frame structure. If you can recall if you are a very observant person, you see a building, a high-rise building with all metal cladding around it, curtain wall, we call it. You can imagine what kind of frame inside. So the frame is something like this, okay? Something like this. Maybe kalau if 30 story, then it goes up 30 story, something like this. And it's all cladded. If it is RC frame, concrete frame, reinforced concrete frame, then you won't look like this. We'll talk about it later afterward. Okay, next one. The members, these members are usually connected together with the correct sequence to form structural framework. Okay, of course, the connection we'll be discussing in future lectures how they are connected together. Okay, to make it rigid, strong, and stabilized. Okay, and next one, problem arises when large members are used and when height of the structure makes lifting difficult. Nowadays, I don't see much a problem of lifting this. It's not so much an issue because they can use crane, tower crane, tower crane yang besar that goes very high, like in Lateral, that goes around the covering certain area of the area, especially in high-rise building, use tower crane. Macam ni is on ground crane can be used for single story, double story building, can use ground crane. So in this situation, crane will be need to lift members of crane to play. Rectangular frame are usually made of steel, but also made of concrete. This is another type of frame which we will talk afterward. Okay. Type of frames. What type of frame structures? There are three basic frames depending on material used in construction. Our focus will be on steel frame. On A, steel frame. The second one, just tell you a very brief about concrete frame. Because concrete is not never steel, but to compare what kind of frame or to share the same kind of concept of frame structure. And then we have a wooden frame. Wooden frame, so we'll talk about wooden frame after. There are also a different type of frame depending on the connection between beams and columns. Sometimes we have composite kind of frame pada juga. Okay, let's talk about steel frame structure. I call it common type of steel frame structure because there are a lot of the frame structure. Common means that it's easily that we can understand, we can see. At the moment, later on, if you will master's program, they've got more detail on frame structures. Okay, on steel frame structures. Okay, and the first one is rigid. You got rigid frame structures. Brace frame structures is using bracing. I mentioned some bracing. Portal frame structures. This is for column free, short span, and then normally used for factories or warehouses. We'll talk about it after. Okay, Word rigid implies the ability to stand in the formation. And so that with all the jointing, you got column, vertical columns, you got horizontal beams, yeah, can be universal beam like I beam you see just now, okay, without any bracing. Bracing means across. We talk about bracing afterward. This is this column and beam, just like you saw just now the first slide here. This is rigid, rigid structure, rigid structure frame. They are jointed by this some kind of detailed jointing by rivet or bolt and out, so they become rigid. Of course, without the bracing, the frame has to be big enough to support the weight and so to take all the lateral load and the dead load and live load. Okay, rigid frame structure can be defined as structure having column and beam. Again, column and beam, column and beam. Whatever building, once it is goes up vertically, you have to have column and beam. But there are some building without column and beam. They call it load-bearing wall. That one we are not touching here, load-bearing wall. There are only two types of frame. One is load-bearing wall. The other one is structural frame. Made monothetically, actually same material. Acting together to tolerate moment which are producing as a result of applied load. Moment is about forces. Forces about moment. Moment you move. The building can move. This can also be of concrete structure over there. It also can. And what they call this steel structure is the most practical. Okay. And then this type of this is sometimes this type of steel. Sorry, this type of frame. This type of frame structure. Dia ada main kat sini. It's sometimes called moment resting frame. Connection between beams and column are rigid, rigid, and there is no diagonal bracing members. Yeah, rigid frame. Boleh buat ya. This some example. Yeah, sample the rigid frame. Yes.
Diagonal itu apa?
Diagonal. Okay, diagonal means that good question. Diagonals means that this open frame and from the roof beam to the bottom roof here. Diagonal means that there is a bracing here, another frame here. Diagonal frame, diagonal. Tapi sekarang rigid ada, but when we come to brace frame, you can see diagonal here. Diagonal is jointing from an angle like this to make the frame rigid. Until we talk more about diagonal nanti Inshallah. At the moment there's no. I take some slide. There is no diagonal frame. Diagonal tak ada bracing lah. Diagonal members. There's no diagonal members. Diagonal members from here to there, diagonal members. Diagonal members. This is without diagonal. But for the trusses, of course, they got to have this members, strut and the members here. It can be straight and side diagonal. This to take the load. As we mentioned just now about some basic understanding of structure. Load. Ini okay. Some example. Of course, you can see the frame is big. The beam is quite wide. Even the column, like a double column there. This how been jointed together. Okay. Siapa tanya tadi? Ikhwan dah? Syafiq. Now sekarang we come to rigid frame with diagonal. Diagonal frame. Diagonal, they call it brace frame system. Okay, this frame system offers more effective resistance against the wind force. Wind force. Lateral wind force will relate to dipanggil lateral load that come from the sideway. Rest building, why the Burj Khalifa is tapered that way from bottom very big, wide, and it goes up, it tapered, tapered to the top until the space becomes smaller. Why? Because of the lateral load. They want to protect the lateral load. Once it goes higher, the wind force is very high. So if the building like it goes up the same size, like our 118 tower, it's the same size, then the lateral load is very, very strong, and it may affect the foundation. Maybe our foundation building is not big in terms of scale. I mean, talking about just like a finger pointing up, macam nipis dia, it's very high in terms of scale kan. Maybe the wind forces is being reflected through the edges, the curved edges of the 118 tower. Kalau it is like you have a block of square rectangle block, it goes up like 80 story, and then you have a problem of lateral load. Lateral load come from the side, the wind can push the building. My experience in studying Sheffield, my room is somewhere in the 14th floor of they call it Arts Tower. There's only high-rise building in University Sheffield. When the wind come at night, the building shift by about 450 mm from the base. I think this research by media. The building move 450 mm, the top of the building, topmost building, move 450 mm, but kaki setengah from the bottom, from the base. See, this is the kind of lateral, because building there is like a square building, it goes to the top. So, but engineers have taken that consideration because one thing about steel structure, it can move. It's allowed to move actually. But if you're talking about concrete structure, you cannot do that. It causes a lot of cracks. Yeah. Okay. Wind forces tadi kan, earthquake, yes. And it's also more effective than the rigid frame system. To take up earthquake, because earthquake you move, and then this one can actually like they are playing soft among each member so that they can take the load. Kalau you're talking about Taiwan 101 tower. Kat Taiwan tu yang tallest, second tallest building tu. Taiwan tu on top of the roof of the what you call this on top roof, there's a big ball hanging from the ceiling. I mean frame ceiling lah. That ball somehow or other will balance the earthquake. Once earthquake happen, that ball is counterbalance it. That is interesting. Itu kalau check up seismic lah. Seismic is earthquake system. This is good for frame structures. Okay, these members in a braced frame are generally made of structural steel, which can work effectively both in tension and compression. Okay, with this type of frame, bracing are commonly provided between columns and beam. Bracing in column beam, in between column beam, to search their system beside the sideways forces and lateral forces because of applied load. That is lateral load. Bracing is typically done by positioning diagonal members amidst the columns and beam. Okay, and I will tell you basic understanding of bracing. Okay, now we go to this understanding of bracing. Okay, if you take for example, goalpost. This is something like goalpost, straight goalpost, without the one at the back holding the neck, the net, without the neck, goalpost by itself. Okay, with the joint, everything. If you apply a load on the goalpost, a very heavy load on goalpost right in the middle here, somehow or other the goalpost will either sway to the left or to the right, isn't it? Betul tak? You put a load here on the goalpost in the middle here, it will bend a bit, but the load is more than the goalpost will sway to the right or to the left. Depend on the weakness of the joint. This is something what we call it sway, S-A-W-A, W-A, sway in the building structure. So what do you mean here? What is sway and non-sway frame? A frame is considered to be non-sway, braced, if it is sufficiently braced by lateral bracing moment like such a wall. On the other hand, frames that provide lateral resistance only through columns are considered to be unbraced, sway frame. Just that. Okay. But if we are talking about the same goalpost, okay, we put a brace. Of course lah, goalkeeper tak ada di situ lah. We put a bracing, a brace here from one point to another, put a brace here. If they apply load here, the load, if it is, it can go, it push down, but it cannot go to the rigid structure because the whole frame should be held back by the brace, diagonal. Ini diagonal, you mentioned tadi. diagonal blocking movement, the block the movement. So the sway and non-sway problem is one of the reasons why that we like to use bracing in our structures. Simple X bracing will be prohibit the movement of top part, meaning that it will have a non-sway system. But it always do. Also. It depends on the load, on the size of the structure. If it is too small a size, too huge a load, then it will sway also. It will break and will collapse maybe. Okay, more on this on this simple structure. Okay, what simple structure frame? Basically, the frame of structure having combination of beam, column, slab to resist lateral and gravity load. Lateral, sideways, wind load. Gravity is top load. Less structure are usually used to overcome the large moment developed due to applied loading. Okay, this all depends on loading. And this is some example of the simple frame structure. It's very started like this. You imagine you did kemah, you know the stand for the wedding reception that you build in front of your house. You assemble in front of your house for wedding versus the frame. You look at the frame; it's very simple frame, and yet it serves the purpose. That one can be like IBS kind of thing. You can dismantle, you can keep and assemble. They simple frame structures. Okay. This is a more simple frame structure, but still without bracing. But this one bracing here. Simple, but still this is rigid. I just want to talk about the why that we need some without bracing. If it is too strong a load, I mean the wind load, and then this building can also sway. Similar for this one. If too strong a load, this building can sway. Similar for this. If it is the column is close together, it's not too bad. If it is big column like this, very large column, 40 meters and above maybe, then we can start to sway. Especially when your roof is solid, the wind pressure on the roof is very heavy. Again, if you're having like crane, a mobile crane that slide here, you happen to see some of the factories that carry big load. They got a rail here they got what they call it. Some lifter that can carry the load and move the back and move around. Okay, another one about sway. Okay, it's a more similar thing we do. Load here, either the column blocked in that way or this way. It depends on where the load is moving. This they call lateral load. This lateral load is wind load. Sideways load, sideways. Gravity load from the top. Vertical load, they call it the vertical load or gravity load from the top. Lateral load also sideways. You can sway this one without bracing. Okay, but you have a bracing vertical load, then only this is only bending if the load is high. But the bracing is taking place to take up the sway effect. Pin joint. This brace gravity load. If it is lateral load, same also. You have that, and then it's supposed to move that way, shape. But because of the bracing, then it won't stop swaying. So that this kind of concept of bracing it applies to a lot of building structures, from low-rise to high-rise building. This is a very the name of those bracing type. The V bracing on the shape V bracing, inverted V bracing. Still have diagonal bracing study. I think remember what diagonal bracing, diagonal X bracing, K bracing. I don't know what they call it, K bracing. Maybe there's K, word K there. But some other, they term it something else. I mean, quite a lot of bracing. You're talking about architectural bracing. I show an example later on. It's coming soon. About what I mean by bracing that is related to engineering bracing and architectural bracing. For architectural bracing, I don't know whether this doesn't fall to any of this type of bracing. This is basically typically of engineering bracing to take up the load. But when it comes to bracing, there's so much of what they call this design factors that influence the bracing of the building. Okay, let's look at the engineering bracing. This is engineering bracing. For the simple structure that we showed just now, this is we call this portal frame. Portal frame. This is portal frame. We will look at this portal frame. This portal frame without anything with the portal frame. We will touch about that shortly. This is on some sample bracing. Look at all this bracing. This is like V bracing this one. No, K bracing, K. K here, K here. The K side and K that side. Sorry, this is K, but this is brace. This whole thing is V. Look at this. This is like V. If you take this one, like K, remember. These are all inside there. And this is bracing for a long span structure, for a big factory. You know how bracing ensure the structural thickness for the building, and this is normal bracing. The engineers depend on the engineer how they design it. Some engineers they over design. That's why the members is big. I've come across in my practice engineers that is very safely designed, engineers that is like they're giving like 10 safety factors. People are talking about 4.5 safety factors. Meaning the load that you put, if it is 100 kilonewton, that means they can take like 400 kilonewton. Macam tu lah, 4 times such a load. Our Malaysian building is okay. They design structure, always over design in terms of structure. Okay, that's this is also engineering. Okay, this is inverted V bracing with steel frame. This is in London building by Norman Foster. They're bracing by side wing that goes like a spiral like. Similar for this one. This is engineer but also architectural bracing. Engineering but this also architectural bracing because some design feature there. But this is totally engineering bracing. Let's see the architectural bracing. No, wait. Okay, this architectural bracing. How do you term this architectural bracing? I saw this skit like the satu. Look at the building. This in Dubai, I think. Look at this bracing. It's so organic. It is like inorganized in a way, but it creates a pattern. It is not uniformity. There is no uniformity, but it's a sense of rigidity there, because it's framing all this. The organic form opening here. This is the overall building. The outside frame is maybe engineering structure, bracing. Come to inside is the architectural bracing. Similarly for this one, bracing can be looks this one like engineering, but we could look at the detail of the bracing with the frame which is being designed like molded form. This is all the architecture. This is what I mean by detail in design with detail in mind. I'm giving a talk on design in mind to first year. Design detail in mind. If it is engineering, this is no detail. Detail is only for connection detail, not design detail. Connection detail, this kind of detail. But it is engineering. Nothing very architectural about this. Engineering. Ini tak nampak detail. But for the one that we see here, this is architectural detail. Okay, so I always focus telling the student that you have to design something in detail when you start designing. So design with detail in mind. The thing you do when you got this kind of idea of, for example, you see this picture here, and then you capture that bracing can be designed architecturally pleasing to the eye, and yet it serves the purpose to withstand the load. This is what I call it design with detail in mind. You create a curvature kind of thing, not very sharp, very harsh, very crude, jointing, engineering jointing. This is architecture. This architecture detail. Then they do that kind of edges, that slanting, sloping facade within the so-called bracing area. Architectural detail. They create a line here between here to stress the line of the frame. You can see a more express kind of frame. In this detail, this is in terms of cable bracing by cabling. I mean, engineering and architecture combined together create some web like structural web pattern, like spider web pattern. to give some sense of design to the place, especially in connecting or holding a glass wall. Interesting. Yeah, I need to give a very grand vertical facade. They kind of cross elongated X frame. Maybe engineer will do this, but because of the expression of some curvature, to look like there's some curvature to the surface, and that engineer will have to crack the head to do this. But architect intention is there. Because bracing is one thing, engineering to satisfy the loading factor, the safety factor, but you can add together with architecture aesthetic beauty to the building, to give the building a bit elegant look in a way. This is example like this. This is, I think there's a railing here. Why the taper could have make it straight, but because nature of this, what kind of form? I panggil ni form kuih lapis, lapis, then the railing is there actually. So they could have done it straight, so it doesn't harmonize. If you put a straight beam here, it doesn't harmonize with the in and out of this, that gives another like a detailed design again, sloping a bit so that harmonize that form, gives harmonizing factor to that form, not this form actually. This talking about expressing this side of the facade. Okay, there is architectural bracing. Okay, what's next? Okay, this is portal frame. I mentioned about portal frame just now. The structural members, portal frame, is a type of structural frame that is characterized by beam and supported either end by columns. Beam, column. See, beam, column, beam, column. Okay, beam, column. This is maybe perimeter beam. This one is another. This is column. Okay, sometimes if they spend too long, then probably they have some column. If not, it is like having a column at the back. Okay, portal frame are usually made of steel, reinforced concrete, cast concrete, or laminated timber. In the timber in Malaysia, they call it glue lamp. It is quite widely used in Europe, Sweden, Scandinavia, because it is of timber. They glue timber together. That timber can take very high load, just similar to steel. Okay. Portal frame are prized for their structural efficiency because of column-free structure. With this type of structural frame, large space can be built and enclosed with the use of few material as possible. This is huge advantage for builders because it helps them to minimize cost. In Malaysia, a lot of these buildings they constructed in they call it warehouse or factory, small factories, not small factories. A lot if you go to industrial area, whether it's Seremban, Kuala Lumpur, PJ, they're all industrial area, you can see a lot of the frame structure being erected. Similar for this one. Of course, the engineer have to design whether they have to maintain this as a uniform size, whether to have to widen the beam as the load is very small here. The load is still coming here and transfer to this. Maybe okay, the beam is tapered because in response to the load structure. This the beam is tapered. Here it's tapered response to the load structure. This is less load. It goes in and the column take it the whole. They're taking all the whole load. This one you got bracing. Remember, instead of bracing, bracing normally is applied to this kind of building. Once you have a large, long building, you need bracing from lateral load and juga from the left load. Okay, that is so much about. Okay, I mentioned to you we touched a bit on concrete frame because there are also frame structures. What is reinforced concrete? You know what is reinforced concrete? It's the use of concrete is a basic material. Basically, is made of cement, sand, and the stone. That's what I call it. I believe that. Concrete have to mix with water. The system depend on the grade of concrete. The lower the grade, the less cement it is. The higher the grade, will be the grade like grade for foundation of the KLCC tower. The grade is very huge, 32 or 40 grade. I mean, very hard and solid. Just like the steel, you got more carbon, you gonna get hard and solid, but brittle. But for concrete, it depends on the load structure, the amount of load that you're taking. Then the harder the concrete, the higher the load you can put on. So concrete basically is monolithic. So reinforced concrete structure basically is horizontal beam and vertical. Beam, I call it horizontal element is beam. Vertical is a column. The element is column connected by rigid joint. All this is cast together. This structure are cast monolithically. Like I mentioned tadi, is beam and column are cast in a single operation in order to act in unison or to act together simultaneously. Have to cast. If for the casting, we take floor by floor. One floor. Normally, they will do for this floor, for example, for ground floor, example, first floor. The bottom floor is already cast, the floor slab is already cast. They already put the concrete, but before that, they have this reinforcement for the column. On each column to continue. So the reinforcement is ready, and then the reinforcement on the floor is ready, they pour concrete. Okay, pour concrete. And then at the same time, they pour concrete for the column, It goes, and then the next floor, they do layer by layer, cast at one time per floor and per floor. Some is too big, and then they break, maybe that compartment. The other compartment, they go in stages. The best is they cast at the same time, so that there is no cold joint. Cold joints mean that you cast at different time, it can create cracks. Why that your terrace houses sometimes they're full of termites. Before you know that it is constructed of concrete beam, and ground beam concrete, floor slab concrete. Why? How the termite come in? How do termite come in? Termite use what the breaker, concrete breaker. It's not that, because why? You cast the floor beam, ground floor beam. Beam is joining column to column. For example, you take the ground floor. It's ground floor here. You cast beam first for ground floor. Here lah ground floor. No, this is this foundation, the red foundation in the ground floor. You cast the beam first, beam first. Okay. Later on, only you put the floor. Once the beam and the floor, it's been cast at different time, then they create what they call this cold joint. That's why that concrete has to be rigid, has to be cast together. Once you create cold joint, there is some minor crack will be found in between beam and slab and floor slab. This is where the termite come in. The termite come in, they will attack first your door frame, timber door frame. Of course, now it's already most of the frame made of steel. Governance iron dah tak ada lagi dah. So the termite has a tough time to. But they can still come in through, but they go up to your roof. First they attack whatever on the floor. If you have some box, the most favorite material they like is your paper box, and then go to your books, your shelf, and then you can up to your roof, trusses. This is how the truss can collapse, because of this cold joint effect. Okay, this is how it's been constructed. Just mention to you that most buildings in Malaysia were built with concrete structure frame. Whether you can see here KLCC. I mentioned here why. Anybody can tell me why that Malaysia's building, especially whether it's low-rise or high-rise, is basically constructed with a concrete structure frame. Anybody? Siapa jawab? Tak apa lagi, tak apa, salah tak apa. I welcome the salah. I just wanted to answer. Why?
Because of the weather.
Because of the weather, okay. Lagi? Hebat tadi?
Yeah, I was gonna say climate.
Okay, climate, okay.
Is it cost as well? I don't know.
Cost can be expensive compared to steel.
Oh.
Time consumption is even is longer compared to steel. Why did Malaysia?
Because of the thunderstorm.
Yes, steel building can take thunderstorm, concrete building can take thunderstorm. That is lateral load tadi lah, mention about lateral. Okay, I ask you, how many steel factory you see in Malaysia?
Tak tahu.
Steel factories.
Berapa?
Can you name one or not? You seldom see, isn't it? The biggest one last time was Pewaja. Siapa? Those who stayed in Terengganu, especially Cukai. Cukai No. Pewaja kat mana? Kat Petronas punya town apa nama? I think sebelum sampai Dungun kot Pewaja. Pewaja is government steel factory. It's a huge. They spend billion. But end of the day, it's collapsed. We got in Bukit Raja in Kelang, there's one steel factory there. From they produce steel product. They're not many. They are about I think not more than 10 or 10 plus there. Factory. Because one thing about the material is not much available in the country, and then the workers are not much what they call this trained to construct with steel. Because concrete is abundant in Malaysia in terms of cost of material, it's cheap. It's abundant because we got so much of granite, so much of sand, so much of so many what they call it cement factory. So the best option in terms of cost of material is still concrete. But still, again, why the Petronas in Tower? It is designed by American, built by the Korean and Japanese, owned by Malaysian. Petronas International, if American for that matter, they would rather use steel, but they use concrete slab. Because why they mention that? Because steel is not popular in Malaysia because of the unavailability of the material. And then the workers are not actually trained to build using steel as a basic frame material. That's why that in Malaysia, concrete is the best. Even though the time taken is a bit longer, I know they're going for IBS, Industrial Building System, maybe it's a bit faster. But even that also is not that popular yet, because they have not achieved the target. By now, they should have at least, according to IDB, the Construction Industry Board Malaysia, prefab or IBS for that matter, Industrial Building System, should achieve 2020 about 50% of construction work. So far, they have not done yet. They have not reached that yet. This is about concrete. Concrete can be in something else. Okay, next one. Wooden frame. This frame structure offers several advantages like beauty, versatility, durability, high strength, the weight ratio, good electrical insulation, thermal induction, excellent strength and low temperature, has high shock absorbance capacity, can withstand large overload, short time, depend on size of frame. You can withstand easily to shock curvature, can move over. And then finish decorative, but it's very nice, warm kind of material. When wooden frame are used, the wall are continually built with slender stud space. Depend on spacing, it depends on this. But this is really from the building. Let's see what kind of sample of wood frame structure. For example, we got the A-frame house here. You can use the space A-frame. These are all structure, and this is not balloon structure that I will mention up here. This is single structure. This is structure for, you got column, got bracing, small bracing here to support the wind load, and the rest are all frame. The trusses is made of timber, the pulling is made of timber. Similarly for this structure, all the space in between is just infill panel. You can have a timber board infill panel with studs. You have some other board to surround the material that can fill up the space here. It is similar to our Malay kampung, the traditional Malay kampung. It's all with frame structure. Start with column, then you got joist, you got barrel, joist, you got rafter, all the frame. The rest are infill panel. This is the finished product. These are infill. The wall, windows are infill. Between columns, supported by the barrel, the one is supporting the joist and then the floorboard. This is for ventilation purposes, so that because of the hot air in Malaysia, the hot air will be flushed out through this gable end. So this is timber. Okay, other type of frame structure. Other type of frame. Okay, space frame. Okay, space frame is considered as a long span. It can span very long without column in between. This is one example of space frame structure. Balloon framing is a members which they create a lot of these studs to form the frame. This is not commonly in Malaysia, but it's quite common in US. But if you see if there's a case of cyclone, when you see on the news, the cyclone will actually wrap everything out and throw all the pieces of timber together. Unless kalau it is in Malaysia, probably they will leave the roof, but still the concrete wall still stays. This is timber. Okay, for still the space frame structure. Sorry, this is steel frame structure. Yes, almost among most weight efficient form of lightweight steel structures. Element and nodes separated and bolted together to form a frame. Geometrical shape can be either curved or flat, with many variations on grid types. This is by using small members. We learn about some basic principle of structure just now. Come in members, but it's not 2 dimension. It is like 3 dimension. You can see here. You can see also 3 dimension. It's like a web, 3 dimension. So it can take a long span and can take its own load. This one we will discuss later on in our long span structure with some detail, what they call this, study on this one. This is some example, space frame. Example like Zaha Hadid IDF Museum in Uzbekistan. It's very nicely curved space frame, which is assisted by a very advanced computer software to create that each member here is very different, and the joint will be different. As the joint, you create the shape. This is very, very challenging kind of design. But once they finish, until we show you later on, it's very smooth. Like it is so fluid. It's like fluid in the form. Building is so fluidity in the forms and full expression. This is another simple vaulted kind of frame structure that has a consistent length and shape. This can be repeated. Similar for this for train section, they use for the last train structure with some light, what they call this, translucent finish or glass or acrylic to give some light, direct light to the interior, so you don't need to actually put artificial light. There's some all this on curvature kind of form, curvature, some like straight form for space frame, and this is also a frame structure. Okay, and I think you come to the almost the last one. Okay, what's balloon framing? Okay, balloon framing makes use of many lightweight wall members called studs. This is stud. The vertical members here is stud. Okay, these are stud. Vertical members called stud. It is spaced very close together. Maybe about depend on the height of the building. Like what we use in, I mean, this kind of concept can also be used for steel. Until like this complete steel frame, we will be looking at some similar feature of this. I can show you some of our experience in doing the SDNE, the Mizan home in Dubai for the stud. But for this timber, it's almost similar to that kind of construction. So they use stud and the rest is the same. But the wall is supporting. And the wall is supporting the load. Okay, and we got this ledger. And then in between some logging. Logging is to hold the stud together. Okay, rather than fewer heavier support for the post, we call post. Balloon framing components are neither together rather than fitted using joinery. So they join together, but most of them using nail. They nail it. The name comes from each floor level being framed as a separate unit of platform. Okay, and then room framing is a style of wood house building that use long, this is vertical, the size lah, 50 mm by 100 mm for the exterior wall. So this long stud extend uninterruptedly from the seal here, from the bottom here, from the seal plate, from the seal on top of the foundation all the way up to the roof. Some also assume this type of framing could only be used in utilitarian or box-like building. But most of the, I see most of the US building is housing, mostly individual house, a single family house is made of this kind of construction frame. Okay, we are coming to material used in frame structure. Basically, you steel, wood. You mentioned wood, you see the wood frame just now. Steel, this universal beam, the I-beam for long span ataupun short span structure. This concrete, aggregate, we call it aggregate. The small stone called aggregate, cement and sand. They mix together with certain amount of cement. Then they pour it to become monolithic together with a ready-made kind of reinforcement being fixed before they actually pour it, so that become rigid. And once it dry or cured, you call it, for the cement, concrete, you call it cured, you call it dry. Once it's cured, and then you can take out the what they call the formwork below, then it will stand its own load and also take other loads. This kind of material. Okay, let's see some advantages of frame structure. So, of course, in 3D construction, it's possible to do simple geometry. Can be constructed more rapidly than ordinary wall structures. Consists of only column and beam, that's the main structure, or possibly floor slab to tie all the beam and column together if you have multi-story building or more than one story building. As the main structure element, it's possible to carry out several building construction activities, the construction of framework of the upper floor and finishing on the lower floor simultaneously. Hence, speed in construction is a frame structure can be easily achieved. What he meant here is that you constructing your floor slab on the 5th floor. The floor below, you can only do some interior work, provided there's no leaking of those what do you call this, wet concrete to the lower floor. This is no problem, it's very well protected. Okay, the strength, stability of structure is small. Okay, we also have a rigid structure. Multi-story structure can also be constructed. Yes, of course. Frame structure is better resistant to vibration than to seismic load. Vibration frame structure can resist vibration effectively and hence are ideal for building in seismic zone. Peter, in our country, I think the so-called earthquake is approaching. It's coming closer to us. Here are some earthquake experience in Gentung. That is close to Genting Highland. Genting Highland. This is coming closer. Last time when there is a what you call this, the catastrophe in Aceh. Apa namanya? What is it? Catastrophe Aceh. Yang habis pembangunan hancur. Earthquake that caused a tsunami. Okay. See, slow that caused tsunami. Earthquake in the areas behind the island of Sumatra. It is top near Aceh area there. And imagine the vibration can be felt until in Penang. When I was there in Penang. When I was in Penang, I was having a kenduri, wedding ceremony of my cousin. I was carrying something in my house. Suddenly I feel like it is moving. Something like, hey, I said I'm not well or something like, I'm carrying something like not like falling down, something dizzy, you're not stable. Apparently, 1 hour later, somebody mentioned that Kuala Muda, which is not very far from Penang, had been hit by tsunami. I think 1 hour later, hit by tsunami. Yeah, so many died. In Malaysia, about more than 30% died there. I think more than that. But of course, overall, it's about only 100,000, especially in Aceh, India, Ceylon, Sri Lanka, and whatnot. Even reach to what do you call this? Near the African country. Okay, that is talking about seismic. What abrasion and vibration can do to building. The most frequent seismic area in Japan, Japan, Taiwan. Okay, number 5 here, frame structure are very rigid and stable. And structure able to resist tremendous vertical load, as well as lateral load, earthquake without substantial deformation or reflection. But again, this is probably applied to steel, if we are talking about steel and timber. But with this concrete, it may cause some crack. Once it's cracked, then the building is not safe unless there's some solution to strengthen the structure. And then number 6, dead load is reduced due to absence of thick load of bearing wall. For steel structure, yes. Bearing wall, not bearing wall, meaning the wall itself is load bearing. If you are, I was teaching semester 5 when you're doing the housing project. Okay, so the whole the unit of the housing is built of concrete wall. That means from below, they're supported by, they call it transfer beam, a huge beam. In all the floor on top, all the floor separating the walls, the unit are made of concrete. That itself is become a structure by itself. So that is heavy. It's very heavy. Unlike we're talking about steel, it's just infill panel. Just you can fill up some very light partition kind of thing. Okay, 6 dead load reduce the absorption of thick loading. Okay, 7 every floor being finished become covered to protect the lower floor from rain and sun. Just like it's now, you do casting on the top floor or fitting the frame on top floor, but the lower floor you can do all the finishing already. Okay, flexible dimensional space necessary to construct wall on walls. Any walls can be taken anywhere, hence flexibility issue. This is for renovation purposes. Somebody renting the floor, then you can do quite easily, and very fast as well. Adaptable to almost shape. Shape not only just square, rigid, but can have organic form. 10 basically frame structures can be easily altered within the limit of the frame. It is possible to change the position of panel wall to meet the requirement of any time. Thus, the greater freedom planning can be easily. Again, this is only internal panel wall, but not the frame itself, not the structure itself. That's why you cannot touch it. When you take out the structure, and then the building become unstable. 11 of site operation is possible in frame structure, especially for fabricated construction using precast concrete or pre-cut structural frame or structural concrete element. This is especially for steel, very good. Based on engineer's drawing, they pre-cut and create holes for bolt and joint and all sort of things that required for that particular frame. And then they come to the site, bring to the site, and just install piece by piece in place according to the time of solution. Lastly, easy to analyze and design structures, including computer-aided design, due to simple geometry, easy method analysis. Of course, for a simple rigid frame like geometric frame, okay, like talking about the architectural bracing just now, then it's a bit difficult. Then give a bit nightmare to the engineers. But the current software, I think there's no problem. Okay, the last stage of our lecture today is regarding about manufacturing of steel. Because I just add to this subject because this subject is not very much, just to know only. It doesn't have to have a separate lecture on this one. We just understand a bit of this so-called concept of manufacturing of steel. And then on the day, I try to show you one, what do you call this, video on the steel. Okay, how steel is made? Produced by 2 main routes. There are 2 routes. One is they call it the blast furnace, basic oxygen furnace, blast furnace, BOF. Route, and the other one is electric arc furnace, EAF. Variation and recombination of production routes also exist. This is the same concept apply, but it's quite difficult to understand because we never see. Unless you see the video, then probably you understand better. The key difference between the route is the type of raw material they consume. Okay, there are 2 types of raw material. The first one, the oxygen, basic oxygen furnace, BOF, they use this basically iron ore, coal, recycled steel. Okay. Then the EF, the root produce steel using mainly recycled steel and electricity. Not only iron ore, even coal, limestone also, I think. And then they create coke, or they call it coke, I think, small pieces. And then they actually blast it in the BOF and EAF, then it become molten, and then it turn into some solid form of steel. Directly, it's something like this. Coal, iron ore, Fe is iron ore. Coke is a product of coal. They combine to the small sizes of coke and limestone. They add together, go into the furnace. This is oxygen, burning by oxygen, according to including the scrap metal that they carry from the waste from the backyard, from waste from the construction site or demolition site. They put here, they blast together, then create this cast iron and into ingot. At the same time, they convert it into, they go to another system here, they mix with natural gas. This is through the electric arc furnace, and then they burn it. Here, the final product will come here. This one we show in the video of that. They will show in the video of that. Total approximately 70.57% steel produced using the oxygen furnace. Burning oxygen furnace, the first iron ore are reduced to iron, also called hot method of pig iron. So pig iron is product of the iron ore. Then iron is converted to steel in BOF after casting and rolling. The steel is delivered in terms of this section coil bars. Similar AF usually use electricity to melt recycled steel. Additives such as alloy are used to adjust the direct chemical composition. Electrical energy can be supplemented with oxygen injected into EF. And then downstream process stage like casting, reheating, and rolling are similar to those found in the BOF route. So about 28.9%. This is 19. Sorry, this data is 2017. Quite. All right. Lastly, I don't know how to do just the video, but I put support video so that I don't forget this. So now I'm going to stop sharing this. I will share you, or can we? How do I move to another? I get stop share and. Wait. Can I share?
Video ke kat mana je?
Dia dekat WhatsApp.
Kat WhatsApp.
Bolehkah kalau dekat WhatsApp sekarang ni? Ya,
Haji try share sikit lagi yang
nampak dah WhatsApp ni? Nampak dah WhatsApp ni?
tak nampak.
Oh, tak nampak. Okay, let's see. How do I share screen? Kena close je kan?